Well, welcome to the Headless Down with Cloudinary Bootcamp course lesson number 10, an overview of video codecs, containers, and compression, presented by Becky Peltz, Curriculum Program Manager, Developer Education at Cloudinary. I had to say that carefully because it's a long title. If you want to learn more about her, I have a great interview with her in the introduction section of this course. Go check it out because she's has great knowledge and we have a great conversation there. But with that said, let's go ahead and bring on Becky here. Becky, welcome. Glad to have you here. I'm going to let you get started. And for those of you watching live, put in your questions in the chat. It's all yours, Becky.
Hey, thank you, Marcel. And I'm happy to be here. And today we're going to be looking at codecs, containers, compression, transcoding. So you're going to learn some new terminology related to video. You're going to learn about video properties, and you're going to be able to understand why compression is so important when you're working with video. So let's start by properties. There's a couple that we can see pretty clearly. Well, one we can see really clearly, duration. If I go into YouTube, for example, and I look at the bottom, I'll see the length of the entire video and then where I'm at as I'm moving through it. So duration is a pretty easy one to see when you're online. But now we might want to figure out size. And one way that we might do that is that we would download that video. So let's say I'm in YouTube and I go to download the video. First thing I'm going to see is this. Notice, well, it wants you to choose high or medium, and it gives you a couple of numbers, 720p, 480p. What do these numbers mean? And how would I make this decision? Let's talk about 780p or 720p and 480p. What those represent are the number of pixels in the height of the video. And the way that we look at video on a desktop or on our mobile device is we are seeing it via its resolution. So width times height gives us the resolution. We also look at it in terms of aspect ratio. So here, all of these videos types that I'm the short name, so base, wide, standard definition, high definition, full high definition, 4K, they all come with a certain height. But if you look at them, you will see that they all have the same aspect ratio, 16:9. So with aspect ratio, it's a proportion there. I can calculate the width of any video if I know its height, because we're expressing height to width. So if I just multiply 16/9 by any height, I can get the width. So all I really need to know is one value, and we use height because it allows us to multiply instead of divide, which multiplication may be easier. Anyway, so given that, we now can see that when we're making that choice, we're deciding how tall a video. And essentially, we're also how wide the video too. So let's talk a little bit more about that resolution. A video, like an image, so there is something very common here. Images also have a height and width and an aspect ratio. They also have resolution. But the difference here is with video, we have frame rate. And frames, you can kind of think of them like images. We're going to show a number of frames per second. Each frame has a resolution, just like an image. In this picture I'm showing, this is Leland Stanford commissioned Edward Muybridge to create a video that could prove that at some point in time, horses have their feet all the way off of the ground. So you can see in this. And at that time, shutter speed wasn't very good. It took about 12 cameras on a tripwire to create the first animation like this. But it was the beginning of a whole new era where we could show images over time. And that's what we now know as video. And so frames per second is an important unit in looking at our video. We can think of it as a property. If I have a video like this older video, 11 frames in 1.1 second, it's about 10 frames per second. If I look at today's videos, they're probably 25, 30 on average frames per second. So we are showing a lot more frames now per second than in this original type of video. But let's continue on. So we now have a new piece to our description of a video, the frames per second. I have a climbing video. So it's a woman climbing up a big rock. And just to kind of better understand this frames per second, what you're seeing as you look at these 4 different images, I've extracted frames from this video at different times. I pulled one at 1 second, 5 second, 10 second, 15. And in between each of these, each second, 25 frames are passing. So what we're seeing here is like after 1 second, this is after 25 frames. And then here, 125 frames, 250 frames. So what you're seeing is she is moving up this rock, but we're skipping over the frames in between. So again, it kind of emphasizes that video is sort of a collection of images presented to you over time. Remember back when we brought this up, we were trying to understand how can we see size, and we were going to like download it, and then we were going to look at that. Now we know that in making that download, that we would probably get different sizes based on whether we picked 480p or 720p. But let's look at how you might calculate the byte size, because ultimately we're looking at a file and it's usually expressed in bytes. Well, we start at the bit level, and here's my image of, a frame from my video. That's an image here of a woman climbing. And then we kind of super pixelate it, because really where we're going to get our bytes out of is looking at each pixel. Remember, we can calculate, we know there's a number of pixels height and a number of pixels wide. We can multiply them together and get the total number of pixels in the frame. Each pixel is described by a color channel. So right here, I've just pulled out one and I'm expressing it here in a hex value. So we have a hex value here of a color, and that hex value in turn breaks down into bits. Now, there are many different ways that color can be put together in these pixels. I'm using a 24-bit true color example. That means I'm going to say, if I have my red, green, blue that I might use on the web, I'm going to have 8 bits per color. And then I'm going to have an additional 8 bits for an alpha channel where I can do shades of, for transparency. So altogether, I'm going to have 3 times 8 plus 8. I'm going to have 32 bits or 4 bytes per pixel. So I can actually now figure out, if I know the number of pixels, which is height times width, I can get the total number of bytes per frame. So let's take a look at how big this video might be. Starting out, I have to understand one more piece. I've got file size directly related to duration. What about this factor bit rate? So bit rate is going to be the number of bits moving per second. We can see there's probably a relation between frame size and bit rate. But in order to calculate our file size, we're going to need to use those 2 components. Bit rate is made up of resolution, so height times width, frame rate, which is on average 25 to 30, say, frames per second, and compression ratio. So we need to understand compression ratio to really understand how this gets sized. But first, let's ask the question, why do we need compression? Like, what if I just left it out? Well, let's do the calculation. So we're going to do a little math here. We're going to take a 1920 pixel by 1080 pixel frame and multiply it by our 4 bytes per pixel. That's what we're using, that 24-bit color depth. And we're going to figure out that we get 8.2 megabytes per frame. Okay, so that's a fairly large picture right there. I mean, a fairly large image. Typically I might see an image around, 2-3 megabytes as an original image. But so this is fairly large. Next, I'm going to multiply by a 25 frames per second. So what I end up with now, so I'm saying that they're going to have, for each second of video, I'm going to have 25 of these frames, 207 megabytes per second. So that we're starting to see some big numbers here. Next, let's say I have a 60-second video. So I take my 275 megabytes per frame and I multiply by 60 seconds, and I find out 12 gigabytes per minute. So this is very large, and we're talking about the web here. So that's moving lots of data across the internet to do this. Not to mention that if I'm storing this somewhere, my storage, it's going to cost me for storage. What if I go for 30 minutes, which is a pretty average size video? You know, it's not like a super long video by any means. And now I'm talking about 373 gigabytes for a 30-minute video. And let me just say that if you go out and look around, you're probably going to see that a 30-minute video is more like 1 gigabyte. So this is really, really big. There's a cost to it, both to your user experience, because if a person has to download that or pay for bandwidth, that is going to add up, as well as storage costs. So we know after this, we know that we need to get some compression. And we also know that if we want to calculate size, that compression ratio is going to be a factor. So how do we compress video? What we do is we start with our source and we use a codec. Now, codec is a new term here for you, maybe. Codec is a word that is comprised of two other words, code, decode. Okay, so codecs are basically, we encode and decode. And what they essentially are compression algorithms. So like if you've worked with zip files and you know that you take a directory or a file and you zip it up and now you have a much smaller file than what you started with. This is kind of the same principle. It's using different method to do the encoding, but essentially it's taking your video and it is making it smaller by compressing it. Now, the algorithms itself, there are probably many ways. There's basically three things that are covered in one of these codecs. One, you can get compression of the image itself, intra-compression. So for each frame, it's like an image. You can just kind of apply basic image compression to that. There's also the fact that when you go from frame 1 to frame 2, there might not be much difference. There's redundancy between the frames. That can be removed, that redundancy, and it can be specified, programmatically that, we're going to assume that carries over from one frame to the next, so we don't really have to store that data. And then we also need to think about keeping these frames in sequence. So sometimes we can look back at the previous frame and look for where things have changed and keep a sequence. So maintaining that ability to remove what's not necessary, what's redundant, is a lot of how to think about what's going on when you're using a codec. But basically what happens then is you take your original audio, video, so both of them, they each have their own types of codecs, and so we'll learn more about that. We encode them into a video file, and you're going to see this is our container. And then when we're ready to play them back in our player, we can decode them. And we'll end up back with our full video codec, with our full video footage and audio. So this is the process that occurs, is when you build the file, the container, you encode, and then when you are ready to play on your player, you decode. And the codec is the algorithm that's used for that. So you can go out and experiment with this yourself. You could, we're going to see that your phone, when you make a video on your phone, let's say, your phone will compress that video for you. And if you download it, you can actually get a look at that. And different devices, different browsers use different codecs. Why they do that? It's kind of just going along with the evolution of how technology evolves, different ideas of how to do things. And what I want you to know is, like, I'm looking at an Android phone here. H.264 is a codec. This AVC is a name for it, Advanced Video Coding. And this actually, H.264 is a universal codec, but we're going to see that you're going to probably get that when you make a film on Android. On Apple, you may get another codec, H.265, which is high efficiency video coding. So different codec, and it's actually maybe going to provide better compression on the Safari or Apple device. So we're going to see a lot more of how that relationship between codec, file container, and device or browser works. But you can experiment with this yourself. Now, if you do happen to do a download and you want to really analyze what you're producing in your phone, like what codec am I actually getting? What is my frame rate? What's my bit rate? There is a tool called FF Probe. And this tool is part of a toolkit called FFmpeg. And if you're on Apple, if you're on a Mac, you can use Brew to install it. If you're on Windows, you can just download it and install it. And if you install FFmpeg, you will have access to a number of tools. There's players, there's transcoders, transmuxers. We'll talk a little bit about that. And there are tools that help you to do analysis. So let me just show you what this looks like. Thanks, Marcella. And so I'm sitting here on a terminal. If I run FF Probe, and I'm going to run this on that file that I shared, the climbing file. And you're going to see a lot of stuff here. So first of all, this first part is kind of the banner. You can kind of look over that, or you overlook that, I guess. And then you're going to see there's some metadata in here, so giving us some branding. But what I'm really interested in is right here, this line here, because this kind of relates to what we're talking about. And you can see that this video is H.264, so that's that universal. AVC1, another name for that. And here we're talking about being able to, how this can be downloaded. Then right here, we're getting this is our resolution, 1920 by 180. Here we're getting kilobytes per second. So this will be our bit rate. And then we have this 25 frames per second. So these are the main properties that we've been looking at. The TBR and TBN, these are actually these are like tick rates. So these are used by the codec to kind of simulate time, because it is kind of a time-based thing. So, and you can learn quite a bit more about this, but I think for now, we're going to focus on our codec, and we've already looked at our resolution, and now we have a better understanding of bit rate. That is the number of bits. And just to think about that a little more broadly, quality depends on bit rate. So if I have a really low bit rate, my quality might not be as good. If I go for a larger bit rate, I might have better quality. So there's a trade-off there. Okay, let's go back to slides. So you have the ability to do this kind of experimentation and analysis at home, and it is kind of interesting. So now we know about codecs, these algorithms that we can use to create compression. Now let's talk about containers. Containers are basically you would probably know them by their file extension. They are the definitions of files that hold the pieces that are needed to store and then play back video. So if you're familiar with MP4, this is, again, probably the most universal. This runs on pretty much every device and browser. That is a container. WebM, it is another very popular container, a little bit different compression algorithm intended for web. So you're going to get a little bit better, smaller, faster videos. MOV, if you use Apple, that is a container that you can play on an Apple player. AVI, this is for Windows, a container that you can play there. And then OGG is an older container going back many years, but still reference OGV and OGG being the audio, OGV. So these are containers that are going to hold something. And what do they contain? Well, they're going to hold audio stream, video stream. So those are the basic, when we say stream, that collection of frames that make up the video or the audio. Subtitles. So we're going to see there are ways that you can specify there are different ways that you can specify subtitles. Subtitles show you some text content that matches the time frames of the video frames themselves. Those can be packaged in there. And then the information to bring these streams together. So what is that? So we're going to have the codecs in there as well. So we need the information available so that we can decode those codecs. So all of that is packaged up into a file that has a specific, layout that accommodates all of these different pieces. And then when you deliver that file to a device or a browser, that browser knows how to interpret that file, knows where to look for the audio, the video, the subtitles if they're there, and then how to decode the compressed video or audio if needed. And you might be asking, well, we're talking devices and browsers. Can I use anything, any codec, any container on any browser device? No, they do. There are some universals. We'll see that, but there is sort of just like any technology. Why do we have Windows? Why do we have Safari? Well, people have developed good ways to use those technologies, and so certain processes have followed that. And so if you go to the caniuse.com, you can look and see, where does MP4 run? And you can see here, well, it runs on everything except Opera Mini. So we're looking at these green bars. Or what about H.265? We mentioned that was a better compression that we saw on Safari. And yes, we can run it on Safari and we can run it on iOS, but it's not going to work on these. So this presents a problem for developers, web developers, is that, I've really got to know my codecs and containers, or how am I going, because I need to support people that maybe are across different browsers. And this is a common problem. Or maybe you're in a very specialized area where really I'm just supporting Safari, and I need that to be as absolutely good as possible. So how do I make those decisions? And here I'm throwing at you now a chart that in the beginning looks like, wow, that's a lot of things to read. So let me kind of point out the important things here. But the gist of this chart is to let you see some common codecs, some common containers, and the browser support on these. So you can think of, codecs are going to be wrapped up in a container. So certain containers support certain codecs. And then certain browsers, we know, support certain file extensions. Now, I'm just pulling in a really broad array here, but I'm also showing you some of the most commonly used. And I mentioned before H.264, also known ABC1, universal. So this is going to work on all your browsers. That MP4 container can hold that, as well as a number of other containers. But if I'm trying to support, people that across the web, this MP4 with H.264 is going to be my choice. I'm going to definitely want to be making that available to my users. However, a lot of people are using Safari and iOS. So if I can also make available H.265 on MP4, that's going to make their experience better. So I'm going to be looking at that. And then AV1, I will call this one out, is the more advanced, better encoding for Chrome, Firefox, and Edge. Now, Chrome, Firefox, and Edge all use the V8 engine, the Chrome, the Google V8 engine. So they tend to be able to share the same things. And they also support WebM. So I probably want to use WebM being a better compression. I probably want to look at using this too. I'm also pointing out here with these $signs that some of the codecs are patented and licensed. So there's a cost for a vendor to make them available. And that's another consideration why, why you might not see, say, Chrome offering 265. Although I recently read an article that told me that Chrome has purchased it, but I haven't seen it available. So this is a continually evolving area. I mean, making a chart like this, I could probably throw it away in a couple of weeks because, well, no, not really. But these things do evolve. But there are a few things you can count on right now. And I would say focus your efforts on the AVC, the H.264, H.265, and the AV1. All right. But it's also important to keep that in mind that not every container supports every codec, and not every browser supports every container.
I think it's really important also to point out not just developers need to know this, but also content authors, right? Because when they're publishing through a headless CMS and they're picking a video, they need to understand where is this going to be delivered. If it's a mobile, should it be really small? You talked about frame rates and you talked about compression and support. So it's very important also for content authors to truly understand this.
Yes, and just to throw this out, I mean, I am from Cloudinary. I'm not trying to make a marketing sale here or anything, but that's the kind of thing that a service like Cloudinary provides, is that it can make it easier for you to prepare and deliver all of those different formats. That's a big part of it.
Yep.
But while we're talking about compression, let's just mention lossy and lossless. And so with lossy compression, we're actually like removing bits, and that is the most common thing that you're going to see with compression for video, especially if you're talking about on the web, because you literally have to take some of that stuff out in order to make this, work across the web. And then the better your codec is at figuring out what to take out and what to leave there, that's going to make the quality of that better. So lossless, that's going to be more for like archival video, and you can see that for H.264, there is a lossless version, same for 265, VP9, AV1. All of these have a lossless version, but in general, you will be using lossy. And the important thing about lossy is you don't want to recompress an already compressed video, because you've lost on that first compression. If you reapply it, you're going to lose more, and really the quality of the video will deteriorate. So yes, you want to think about your original is your kind of perfect video, and once you've compressed it, it still looks really good, but you don't want to keep reprocessing that. So how do we code our HTML5 video element? And I've got a little asterisk. Cloudinary has a video tag utility that generates this, but this is just straight HTML5, and you can, of course, code it any way you want. But I want to point out that this video tag takes sources, because we talked about giving your user the best experience in their browser or device. And this source tag within the video is what will help with that. So if you have created several versions of your video, you've run them through some processing so that you have a WebM version and an MP4 and an OGG version, the way this will work for you as your browser will see that source, it will look at the source and it will look at the type, and it will look at these in order. And if it sees the type is something that it can work with, it will pick that one. And so that means that it won't go on and look at any more. It'll say, I can do WebM, and that's what it'll use. So it'll use this URL with WebM. And I think this is really important too, is that you would want to put the WebM before the MP4, because it's going to give you the better experience with the better codec. And so just think about the order that you put this. Now, OGG is the older compression, so I kind of put that at the end, thinking that, well, if they can't do these other things, well, maybe they can do OGG. But so our HTML5 video elements are set up to deal with multiple encodings. Then we get into players, and your browser or your phone has a built-in video player. Excuse me, but sometimes you want to do some extra things. And what I'm talking about here is I might want to get an external video player. And why might that be? I'm showing here a video element versus a player. And basically with the player, they depending on the one you're using, and players are like Video.js is an open source player, and Cloudinary has built a player on top of that, also open source. And then VLC and Flow Mode. There's a number of players out there. They offer different features, but in general, they also, if you're a developer, they allow you to capture maybe many more events, so you can be more kind of programmatic with it. If you're a web developer, you can restyle them. So there's a lot of good things about video players. They also can do maybe a lot more with, like, say, streaming. So they can, and we're going to talk just a little bit about streaming, and I know you have a lesson coming up in the future on it, but they can interpret the protocols for streaming that maybe your built-in players can't. Now we're going to switch just a little bit here to transcoding, because this is another important part of this. Because when I was kind of saying you can process your video to produce these different containers and codecs, so that's transcoding. And I'm showing an example here where you don't always do all of this, but you might. So you can change the codec, the bit rate, the resolution. And so the way transcoding works is I'm coming in, and this might be a video that I created on my cell phone, H.264, 1500 kilobits per second, 640 by 360. So pretty small video here. And I want to turn it into something VP9, 4000 kilobytes, 3840, 2160. Now, this might in fact be a little unrealistic that I'm going to really have the great looking video when I'm going from 360p to 2160, but I can do this. And when you're talking about transcoding, the main thing to think about is that you will uncompress that first video. So you will go back down to its original state, and then you would recompress using whatever codec and container that you wanted. So this can also be used to do that. You may also hear the term transmuxing, and with transmuxing, it's a different process that doesn't involve this uncompression, recompression, so it runs quicker. Like this process of transcoding does take time, and so if you're working with video, you will get used to creating, especially for the developer, or if you are a practitioner, a creator, and you're doing your own transcoding, you'll have to set aside time when you to make these different containers and codecs. Now, just a bit about streaming over HTTP. So if you've worked on the internet, HTTP is the top of the stack. By the time data gets to HTTP, it's nicely sequenced and ordered. That's what we use for our applications. We can actually use HTTP to do streaming. And there's a number of protocols, and we'll see just a little bit about what this means in terms of what's delivered over the internet here. HLS and MPEG-, so dynamic advanced streaming over HTTP, HTTP live streaming. WebRTC, that's a kind of thing that's a real-time communication. That's something you can actually set up, and you could kind of build your own FaceTime in your browser. And SRT, that refers actually to the subtitles. So subrip, title, that's a file format. So all of these protocols can be served over HTTP. And so basically what you're doing when you're streaming is you've got your video file stream, you compress it for transport, and then you segment it. So you're breaking it up into little pieces so that you can move them quicker over the internet to your client. And then you're sequencing them at the client and delivering them into the browser. So that's what streaming over HTTP is. And if we look a little bit more at the protocols here, we've got MPEG dash, so it's going to use VP9. This is more something you'd run on Chrome. And then you'll see that you'll create an MPD, so you'll have this is like a manifest, a list of all the segments, and you'll deliver individual audio and video chunks to your browser. With HLS, you're going to be using that universal 264 or 265. You actually have two layers of manifest. The first is kind of the overall controller, and then these are the sub segments, and you'll deliver TS files that contain both audio and video. So that kind of gets you through the whole breadth of delivering video on the web and how we do it with containers, codecs. And thank you.
That was awesome. Thank you so much. What a great presentation. Great overview of codecs and compression. Something that is really important, right? Especially as we push so much of this content to our users, we want to make sure that they have a good experience with it.
Absolutely. Yeah. In the end, you don't want people sitting there with a buffering circuit.
Right. Right. Yeah. And that's the important part. Definitely. Becky, if people want to get a hold of you, is it right there, that email you're showing?
Yes. Yes. That's my email. Yeah, for sure.
Becky, thank you so much. Really appreciate it.
All right. Thank you, Marcel. It's my pleasure.
And thanks for watching, and remember to continue your journey learning all about digital asset management systems while watching the next lesson, which is coming up in 2023, January. Also, if you want to get your knowledge certification, make sure you use the study guide for this lesson, which you can find in the bonus section of this course. And as always, you can get a hold of me right there, Marcelo@headlesscreator.com. May everybody have a very happy and safe year-end 2022, and we will see you in 2023. Cheers.